Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Today, let's talk about long subtraction. If you don't need help with math basics, just head back in the feed 7 weeks for some more advanced topics. I'm going to share the questions that we're going to answer together in this lesson right now at the very beginning of the lesson in case you want to come back to this episode in the future and quiz yourself on some of the material, which I definitely recommend. If you go back in time, we will have similar questions at the very beginning of each episode in this GMAT Math Basics series. This is lesson 7. And that way, these episodes, if you want, while you're on the go and not able to look at a traditional flashcard type resource, can become sort of like a bank of digital flashcards that you can use to test yourself and retest yourself on these math basics, which just become more and more important as you proceed throughout your studies. Even once you've mastered them, you'll realize just how foundational these concepts are. For most of us, just seeing or hearing something one time isn't quite enough to lock it in on a deep enough level that we would want it to be so that we can perform with it under time pressure. So doing our best to help you out here. And if you have any feedback on how we're presenting this material, then please, by all means, reach out anytime. You can find us on current social channels at the GMAT Strategy. Just shoot us a DM with your thoughts, and we would love to hear from you. With that in mind, here are the questions that we are going to answer today. Number 1, do you know how to subtract very large numbers from other very large numbers without a calculator? Second question we're going to answer today, what do you do when you cannot subtract one digit from another? Because the digit you're subtracting is larger than the digit you're subtracting from. Both really important components of long subtraction and the technical aspects of what we're going to dive into in a moment. Final question we're going to answer today is, what do you do if you're subtracting a larger overall number from a smaller overall number? How do you adjust your long subtraction technique to account for that situation? If you know the answer to all those already, you might want to pass over the rest of this episode and dig deeper into some of our previous content. If you want to understand the answers to those questions better, then you are in exactly the right place, and we are going to dive right in right now. So interestingly, and I think I've mentioned this in past episodes, I actually never learned long subtraction as a young person. And so as a 28-year-old, I think it was, I was sitting there relearning long subtraction on Khan Academy late at night after a full day of work. And that was a very humbling experience. So I'm excited to share and help you avoid some of the challenges and pain I endured in that situation. So starting at the top, if I want to subtract 3 from 7, I might not need a multi-step process for that. And my guess is most of you are in that boat. But what if I want to subtract 7,658 from 13,321 under time pressure in a situation where one mistake in one digit could cost me the entire problem? Well, that's why long subtraction is valuable. So there's just a few steps to long subtraction and then a couple little edge cases, and we'll cover all of it. And by the end of today, you should hopefully understand the technique extremely well. So step 1, just like long addition, if you listen to last week's episode, we're going to start by stacking the numbers. And what I mean by stacking, if you haven't listened to that episode yet, is we're going to write one number right above the other number, and we're going to line up the digits. So we're going to put the units digit of one number above the units digit of the other number. We're going to put the tens digit of one number above the tens digit of the other number. We're going to stack the hundreds digit of one digit above the other hundredths digit of the other number, excuse me. And just on and on through however many digits there are. So you want to make sure that your digits are lining up in that regard. Now, a key point that's very, very critical for long subtraction that we did not have to worry about with long addition is that in long addition, it doesn't matter which one's on top or which one's on the bottom because you can add in any order. But when you're subtracting, the order does actually matter. 7 minus 3 is going to be a different situation than 3 minus 7. Hopefully that makes sense intuitively. If you think about a physical example of 7 apples in a basket and I take out 3 versus 3 apples in a basket and I try to take out 7, those are going to be two very different situations. In long subtraction, that's reflected in the following way. Whatever you are subtracting goes on the bottom, and whatever you are subtracting from goes on the top of the stack. So whatever I am taking away goes on the bottom, whatever I am taking away from goes on the top. So what that means is basically the larger number goes on top. And we'll talk about some nuances of that, but that's a sort of basic way to understand how we're going to proceed. So if we're trying to do 9,234 minus 5,678, which is just 1, 2, 3, 4, 5, 6, 7, 8, but with a 9 instead of the 1, we would put 9,234 on top because that's a larger number, and then we would put 5,678 on the bottom because that's a smaller number. More importantly, the operation we're actually doing is subtracting 5,000 from 9,000. So if whatever we're subtracting from goes on the top, whatever we are subtracting goes on the bottom. So again, just going to repeat that one more time because it's so important. Whatever you are subtracting from goes on the top of the stack. Whatever you are subtracting goes on the bottom of the stack in long subtraction. So that's the first step. You start by stacking the numbers in the right order and lining up the digits. Now, just like long addition, I also recommend drawing a line under both numbers to separate the result from the numbers you're operating on. And the numbers you're operating on would go above the line and the result goes below the line. That's not critical, but I think it's helpful to keep you from missing questions you know how to do. And also it'll help you understand a lot of explanations online that you might come across as you self-study going forward. Once you've got your numbers stacked, then step 2 is simply to subtract the units digit of one number from the units digit of the other number. So this is going to be very similar to what we did with long addition, where we started by adding the units digit. And if you're not familiar with that terminology, units digit, then you'll want to go back to the first lesson of GMAT math basics 7 episodes ago. And I'll talk you through all the basic definitions that you're going to need to master the basic math behind the GMAT. Let's use an example to talk about this stacking and subtracting methodology. So let's say we want to do the operation 87 minus 52. So we're subtracting 52 from 87. Now, I realize a lot of you could do that in your head, but just bear with me as I'm using this to flesh out what we were just talking about. So first we stack, and we would put 87 on top, and we would put 52 below that, because 52 is what we are subtracting. 87 is what we are subtracting from. Whatever we are subtracting from goes on top. Then we would just subtract the units digits. So the units digit of 87 is 7. The units digit of 52 is 2. So in my stack, I would have 7 on top, 2 right below that, and I would just subtract 2 from 7. And then below my line, if I've written that line, then I will have 5, which is the result of 7 minus 2. What that means is 5 is the units digit of the result of 87 minus 52. We subtract the units digit, we get 5. That's the units digit of the result. You might recall that the result of subtraction is called the difference. The difference between 87 and 52 has a units digit of 5. So this is just like long addition so far, except instead of adding the stuff in the units digit column, we are subtracting. So step 1 is stack. Step 2 is subtract the units digit. The third step is just to repeat that process for all the other digits, going from right to left. So the opposite direction that you would read if you're reading in English. Usually in English, you read from left to right. Here we are going to be operating from right to left, starting with the units digit and then moving to the tens digit, and then moving to the hundreds digit, and then the thousands digit. We'll deal with decimal and fraction subtraction later. For now, we're just going to deal with long subtraction of integers, but this basic technique will apply across the board later on. So let's return to our example and talk about repeating that subtraction step within each digit column. So we just subtracted 2 from 7 to get 5 in the units digit. Then what we would do is we would move to the tens digit, and if we have stacked 87 on top of 52, the tens digits are 8 on top and 5 right below that. So we just subtract 5 from 8, and we get 3 as the result. And then we write that below the line at the bottom of the tens digit column. Sometimes this is called the column method of subtraction. That's it. We have now operated on all the digits there. There's only 2 digits in 87 and 52. So we would have 35 on the bottom, and that would be the difference between 87 and 52. So that's the basic set of operations for long subtraction. It's stack, subtract, repeat. Stack, subtract, repeat. If you want to memorize an acronym to help you remember that, it's SSR, stack, subtract, repeat. Let's try another example, and we'll explore some of the intricacies here. So let's try a longer example. How about 8765 minus 4321? I'm trying to make this as memorable and visualizable as possible, since a lot of you are going to be on the go as you're listening to this. So 8,765 minus 4,321 is just 8765 is the top number, and then 4321 is the bottom number. So again, ask yourself, what are the 3 basic operations that we're going to do here, and what's the first step in long subtraction? First step is stack. So we are subtracting 4321 from 8765, and so 8765 goes on top, and then 4321 goes right below that. Make sure all the place values are lined up. So we got the units digit over the units, tens over tens, hundreds over hundreds, etc. Then we will subtract from right to left. Now, if you want to draw that line underneath the 2 numbers before you start subtracting, now would be the time to do that. So let's begin by subtracting the units digits. So we got 8765 on top. 5 is the units digit on top of the units column. And then we've got 4321 on the bottom. 1 is the bottom of the units column. So we just do 5 minus 1. 5 minus 1 is 4, so you would write 4 at the bottom of the units digit column right under the line that you may have drawn there. That's it. We stacked, we subtracted. What's the next step? We repeat that for the tens digit, and then the hundreds digit, and then the thousands digit. So let's do it for the tens digit. The tens digit of 8765 is 6. The tens digit of 4321 is 2. So we subtract 2 from 6. 6 is at the top of the tens digit column. 2 is at the bottom of the tens digit column. We subtract 2 from 6, and we get 4 again. And so 4 becomes the tens digit of the result, or the difference. So we've got a 4 in the units digit. That was 5 minus 1. And now we've got a 4 in the tens digit of the result, which is 6 minus 2. Now we just repeat that until we run out of digits. So in the hundreds digit, in 8765, we've got 7 in the hundreds digit. In 4321, we've got 3 in the hundreds digit. And so we simply subtract 3 from 7. And you guessed it, that equals 4. So we would write 4 at the bottom of the hundreds digit column. Now we just have the thousands digit to deal with, which is 8 on top, 8765, and then 4 on the bottom, 4321. So we simply subtract 4 from 8 in the thousands place, which of course is 4, and we write that 4 at the bottom of the thousands digit in the result at the bottom of our operation, or below the line if you're using that line technique. So what's our result? 8765 minus 4321 equals 4444, or 4,444, which I think is kind of fun. So that's how it goes with long subtraction when you have all larger digits on top and all smaller digits on the bottom. That's usually the simplest situation that can result with long subtraction. We just subtract each of the digits in each of the columns and we're done. That's it. That's all we have to do. Now, let's explore some edge cases that you will probably bump into because it's not always that simple. We don't always have only smaller digits on the bottom and only larger digits on top. So let's circle back to this question I asked at the top of the episode. What happens when I have to subtract a digit that's larger than the digit above it? Let's use an example. Let's say we're going to subtract 37 from 83. Again, plenty of you could probably do that in your head without long subtraction, but I'm just using it as an example of how the technique would work in a more complicated situation. So the first step is still the same. What's the first step? We stack. So 83 goes on top, 37 goes on the bottom because we are subtracting 37 from 83. And then we would try to subtract the units digits. This is where things get a little bit weird because I've got 3 at the top of the units digit column and I've got 7 right below that. And if I subtract 7 from 3, I get a negative value. Now, it's tempting to think, oh, cool, I'll just write -4 at the bottom, but there's no such thing as a negative digit. That can't exist. I could have a negative whole number, but I can't have a number that's like 80 is positive and then the 3 from 83 is -3. Like that just doesn't exist. It's not an accepted convention. We'd have to invent a whole new set of mathematical rules to deal with something like that. And so instead, we just alter the technique a little bit rather than altering all of number theory because our subtraction didn't work out. So here's what we do instead of subtracting from 3. We're actually going to do something called borrowing from the digit to the left. So let's talk about how to do that. How do we borrow? Well, we've got 83 on top, and what we're going to do is we're actually going to borrow from the tens place of 83. So we're going to take one of those tens in 80, and we're going to add that 10 to the units digit of 3. So the way that you do that, if it's written down, is you cross out the 8, and above that, you write a 7. So now instead of an 8 at the top of the tens column, we've got a 7 at the top of the tens column. And then what I recommend that you do is you cross out the 3 in the units digit and you add 10 to it and make it 13. So now you have 13 at the top of the ones digit column or units digit column. Now, 13 isn't really a digit. This is just a trick that ends up working out well with long subtraction. So I'm going to avoid going into all the numerical theory behind why this works. I'm just going to assume you just want to know that it works and to memorize the technique and get a great GMAT score and go to B school. But if you want a deeper analysis of why long subtraction works, there are many, many resources online for learning that, and feel free to shoot us a DM. And if you can't find any, we'll try to set some up for you. But I think for the vast majority of you probably are okay without understanding the deeper math theory here. So let's return to the situation we're in. So we've borrowed 10 from 8 in 83. So we've got 7 at the top of the tens column there. And then we've added that 10 to the 3 in the units digit of 83. And so we have 13 at the top of the units digit column. So now if we return to our subtraction, you'll notice we can quite simply subtract 7 from 37 on the bottom from 13, which is sort of taken over the units digit of what used to be 83. And when I subtract 7 from 13, I get 6. And that is going to be the result that's going to be the units digit of the result. So we do 13 minus 7 in the units digit column, and then we just write 6 at the bottom of that column below the line if you're using the line technique. It's a very, very useful and cool technique. It works extremely well, and it makes subtraction without a calculator much, 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 much easier. So this is something hopefully you'll get a lot of mileage out of when it counts on test day. So let's continue. 83 minus 37. We can't subtract 7 from 3, so we borrow from the 8. We turn that into 7, and then we add 10 to the 3 in the units digit column. That becomes 13 minus 7, and we get 6 at the bottom of the units digit column. Then we just take the next step in our long subtraction process. So you might remember it's stack, subtract, repeat. We're on step 2. We just subtracted, now we just repeat for the tens digit column. So in the tens digit, because we borrowed from the 80, we have 7 at the top, and then we have the 3 at the bottom from 37. So we simply subtract 3 from 7 there. 7 at the top of the tens digit column, 3 at the bottom, and we get 4. 7 minus 3 is 4. So that becomes the tens digit of your result. So what is the result when you subtract 37 from 83? It's 46. 46 is what you would get at the bottom of that operation. So that's the basics of borrowing. We'll do a little bit more practice with borrowing because it can be a little weird if you haven't done it before, but a little bit of practice will go a long way, and I think you'll be really happy that we went through this together if you weren't familiar with this technique before. So let's try a more complicated example. How about 9,234 minus 5,678? So instead of 1,234 minus 5,678, I've just done 9,234 minus 5,678 so that we can subtract a smaller number from a larger number. All right, so here we go. First, we stack. 9,234 goes on top, 5,678 goes on the bottom. We then start by subtracting the units digit. Units digit of our top number is 4. Units digit of our bottom number is 8. So we can't do that without creating a negative. So what do? We borrow from the digit to the left. In 9,234 on top, we've got 3 in the tens place. So we cross that out and write 2 right above it. We're borrowing 10 from it. Then we add that 10 to the units digit of 9,234. 10 plus 4 is 14. So on top of the units digit column, now I have 14. Below that, I have 8 from 5, 6, 7, 8, which is what I'm subtracting. And we just do 14 minus 8, which equals 6. So 6 is the units digit of the result. We write that below the units digit column at the very bottom. That's it. That's borrowing. Then we simply repeat that process for the tens digit, the next place value to the left. Now you'll notice we already borrowed from 3, so we've got 2 at the top of the tens digit column, and we're trying to subtract the 7 from 5, 6, 7, 8 from that. We can't do that without creating a negative, so what are we going to do? We're going to go to the hundreds digit now, which is the left digit from the tens, and we're going to borrow from the 2 in 9,234. We cross off that 2, and we write a 1 above it. Now, I know there it seems like you're borrowing 100, but try not to think about it that way because that's going to get confusing. Instead, just think of it as borrowing 10 from the unit to the left. And I know that mathematically that might be a little bit weird, but I promise that's going to be the simplest way to think about this technique. So then you take that 10 and you add it to the 2 that's in the tens digit of 9,234 because we borrowed from the 3 and made it 2. So now we have 12 at the top of the tens digit column. So we borrowed from the 3, and now we're borrowing from the 2 to the left of it to be able to complete our tens digit operation. So this is how borrowing goes. You just keep borrowing until you're done with your subtraction. So at the top of the tens digit column now, we have 10 plus 2, which is 12, minus 7, and that's going to be 5. We write that at the bottom of the tens column, so the result of 9,234 minus 5, 6, 7, 8 so far has a 6 in the units digit and a 5 in the tens digit. That's that. Now we're just going to repeat that process for the hundreds digit. So in the hundreds digit of 9,234, we borrowed from the 2. We have a 1 on top there, but we're trying to subtract a 6 from 5, 6, 7, 8. We can't do 1 minus 6 without creating a negative, so what do? We go to the left and we borrow. So now we're going to borrow from the thousands place, which is 9. We're going to cross off that 9 and write an 8 right above it. And then we're going to add that 10 that we borrowed. You're always borrowing a 10. We add that 10 that we borrowed to the 1 that it was previously at the top of the hundreds column. So this can be a little much when you're just trying to listen to it, but I promise if you take the time to write this down, if you're capable of writing it down right now, if you take the time to write this down, it should make a lot more sense visually if you're struggling to keep up with this. But the basic technique is there. If you understand the whole column subtraction thing, if you understand the borrowing thing, you'll be able to work it out on your own. And if you can't, just shoot us a DM. We'll get you a video resource, okay? So right now, we've got 11 at the top of the hundreds digit column because we borrowed from the 2 in 9234. We made it 1. Now we're borrowing from the 9 to the left of it, adding that 10 to the 1 and making it 11. So we have 11 at the top of the hundreds digit column, and we are going to subtract 6 from that, the hundreds digit of 5, 6, 7, 8. So you're always borrowing in the top, and usually the bottom stays the same. 11 minus 6 is 5. So that becomes the hundreds digit of the result. We just write a 5 at the bottom of the hundreds digit. Last, we just move to the left and repeat for the thousands place. So in 9234 on top, we borrowed from the 9. That became 8 at the top. And now we don't need to borrow because 5, which is the thousands digit of 5, 6, 7, 8, is smaller than 8. So we just do 8 minus 5, and we write 3 at the bottom of the thousands place. And so we wind up with the result 3556. The result of 9,234 or 9234 minus 5,678 or 5678 is 3556 or 3,556. So that's how you borrow. You just repeat the borrowing process as often as you need to. You always borrow from the digit immediately to the left. You cross it off and write 1 less than that digit above it. And then you always add 10 to the digit to the right, the digit that needs to be propped up or made bigger so that you don't wind up with a negative digit when you subtract. So that's the answer to the question of what do I do when I'm subtracting a larger digit from a smaller digit in long subtraction? I just borrow from the place value to the left. And I just keep borrowing if I need to. All right, so let's take that up a notch. Let's try an example with some extreme borrowing, like multiple borrowing from borrowing. This is what you'll want to do if you have a number like 1,000 minus 283, something like that, where it's all zeros in the top columns and non-zeros in the bottom columns. So basics of the technique are the same. First, we stack. We do 1,000 on top and 283 right below that. Now you'll notice in my first operation of subtracting the units digit, I've got 0 on top and 3 on the bottom. I'm not going to be able to take away 3 from 0 without getting a negative digit, which I don't want. So typically I would go to the left and borrow from the tens, but the left of 1,000, the tens digit of 1,000 is 0 still. I can't borrow anything from nothing. So then I move to the left again, and the hundreds digit is also 0. I can't borrow. So finally I'll move to the thousands digit, which is 1, and I can borrow from that. So I'm going to cross off 1, and I'm going to write 0 right above it. So 0 is going to go at the top of the thousands column. Then I will add that 10 that I just borrowed to the hundreds digit, that's 0 in the case of 1,000. And I will cross off the 0 in the hundreds digit of 1,000 and write 10 right above that. Now, in order to be able to work my way back to the units digit, I'm now going to have to borrow from that 10 in the hundreds digit. So I'm going to cross off the 10 that I just wrote at the top of the hundreds digit, and I'm going to write 9 right above that. Then I will add that 10 that I just borrowed to the tens digit, which is 0. 0 plus 10 is 10, so I will write 10 at the top of the tens digit. Then I need to borrow from that again because my units digit is still 0. So I'm going to cross off that 10 at the top of the tens digit and write a 9 right above that. So this is an extreme case of borrowing, but you might come up against this on test day. And so it's very, very helpful to have worked out how to do this borrowing technique at a more complex level. And that's what I'm hopefully helping you to do right now. So then I take that 10 that I just borrowed from the tens digit, and I add that to the units digit, which is also 0. So now I have a 10 at the top of the units digit. I cross off the 0 of the units digit of 1,000, and I write 10 right above it. So now at the top of my units digit column, I have 10, and then below that I have 3. And finally, I can do my subtraction of the units digit. 10 minus 3 is 7. So I write 7 at the bottom of the units column. That's the units digit of my result. So that's a case of extreme borrowing. If I was going to do 1,000,000 minus 283, then I would have to do that whole process just a lot more times. So I go all the way over till I have a non-zero digit. I borrow from that to make the next digit to the right 10. I borrow from that, it becomes 9. Next one becomes 10. I borrow from that, it becomes 9. 1 to the right becomes 10. I borrow from that. 1 to the right becomes 10, et cetera, et cetera, et cetera, until I work my way all the way back to the units digit. So that's definitely extreme, but hopefully that makes sense that that's the same borrowing technique, just extended to a situation where I have to repeat it a bunch in order to get my main operation to happen. Now, the good news here is we did all that borrowing, but now we have basically all nines at the top of all the other digits. And so the rest of the subtraction is going to be quite simple. So when I move to the tens digit of 283, I'm subtracting 8 on the bottom. And above that, you might recall, is a 9, because we borrowed heavily to make everything 10, but then we borrowed from those tens in order to make the units digit 10. So I have a 9 at the top of my tens column. I do 9 minus 8, that's 1. So the result of that operation, 9 minus 1, 9 minus 8, is going to be 1 at the bottom of the tens digit column. So then we simply continue our process and move to the hundreds digit, which again is going to be 9 because we borrowed from 1, which was the thousands digit. That became 0. Then we wrote 10 at the top of the hundreds column, and then we crossed off that 10 because we were borrowing from that to boost up the tens digit column. All right, so it can get a little complicated when you're listening to this, but again, if you have a chance to write it out a little bit later, 1,000 minus 283, you take a quick mental note of that or note on your phone to try out this operation later on your own, written out on a piece of paper. Try out this borrowing technique, and I think you'll really like it. So the result of all of that is going to be 717, because in our hundreds digit, we've got 9 on top, we've got 2 on the bottom from 283, 9 minus 2 is 7. So we have 717 is the result of that operation. All right, now that you understand the basic approach to long subtraction and you understand how to borrow when you're subtracting larger digits from smaller digits, there's just one more thing that you're going to want to be familiar with to be great at long subtraction. And that's what you want to do when you are subtracting a larger number from a smaller number. Now, if I try to do the regular technique in this case, it won't work. And that's because there's not enough to borrow from in the top line. For example, what if we did 1,234 or 1,234 minus 5,678? So 1,234 minus 5,678. Well, you can imagine doing the borrowing in the ones place, and then the borrowing in the tens place, and then the borrowing in the hundreds place, and then the borrowing in the thousands place. But by the time I start subtracting from the thousands, I've got 0 above the 1,234 thousands place, and then I'm trying to subtract 5 from that. So I run out of stuff that I can borrow from. So it becomes kind of a complicated and difficult situation. So what we're going to do, if you want to subtract a larger number from a smaller number, which always is going to yield a negative result, by the way, anytime I subtract something bigger from something smaller, it's going to be a result less than 0. Then what we're going to do in that situation is we're going to do what I call flipping the stack. So you're going to stack the numbers, but then you're going to invert it, and you're going to take the number on the bottom and put it on top. So if you accidentally write out 1, 2, 3, 4 on top and then 5, 6, 7 on the bottom, then what I would do is I would cross off the bottom 5, 6, 7, 8 and write it above 1, 2, 3, 4. And then all we're going to do to compensate for that is we're going to put a negative sign in front of the result. So below your line, if you're using the line method, all the way to the left of the result, you're going to write a little minus sign, a little negative, to remind yourself that whatever result you get from subtracting the small number from the large number is going to be less than 0. And then you just repeat the technique the way we've outlined it, and it works great. So just remember, if I'm subtracting a larger number from a smaller number, I flip the stack, I put the larger number on top, and I write a negative sign to the left of where the result will go. And then I can just run the technique exactly the way that I ran it before, and it works really, really well. So let's do a quick example, and then we'll wrap. So let's say you want to subtract 87 from 56. Well, 87 is bigger than 56, so you're going to get a result less than 0. You'll notice that if I tried to do 5, 6 on top and 8, 7 on the bottom, I could borrow to make the first units digit move work. That'd be 16 minus 7. But then when I try to subtract 8 from 4, I can't do it. So instead, we're going to flip the stack. We'll put 8, 7 on top, 5, 6 right below that, And then we'll just preemptively write a minus sign to the left of where the result would go. That's it. Now all we have to do is do our normal subtract the units digit and subtract the tens digit. So 87's on top, 5, 6 is below that. 7 minus 6 in the units digit is 1. 8 minus 5 in the tens digit is 3. And then I've got the little minus sign preemptively written to the left, so that's going to be negative 31. That's 56 minus 87 is negative 31. That's it. So quick recap of our skills that we built. First, you learn how to stack. Then you learn how to subtract the units digit first. Then you learn how to borrow when needed. And then you just remember that when you're subtracting a larger number from a smaller number, you flip the stack. That's it. That's it. So let's end with one more example where we finish out 1, 2, 3, 4 minus 5, 6, 7, 8. So that's just the first 8 digits written as 4-digit numbers and subtracting the larger one from the smaller one. So here we go. We start by stacking 1, 2, 3, 4 on top, 5, 6, 7, 8 on the bottom. We can't do this because 5, 6, 7, 8 is bigger than 1, 2, 3, 4. So we flip the stack. We cross off the 5, 6, 7, 8 in the bottom. We write it above 1, 2, 3, 4, and then we write a negative sign to the left of where the result will go. Then we do our units digit first. 8 minus 4 is 4. Then we do our tens digit. 7 minus 3 is 4. Then we do our hundreds digit. 6 minus 2 is 4. And then we do our thousands digit. 5 minus 1 is 4. So what's the result of 1, 2, 3, 4 minus 5, 6, 7, 8? It's negative 4,444. That's long subtraction, everybody, and all the different intricacies that you could come up against on a GMAT exam. So if you have questions about any of this, reach out anytime. We're more than happy to help, and we are still, after all these years, keeping up with DMs. If you've DM'd us in the past and haven't received a response, then we definitely just didn't see it for some reason, so huge apologies there. Please shoot us another message, and we will get back to you. And let us know if there's any different way that we can tweak this math basics course for you to make it more valuable, more interesting, more compelling, punchier. We've worked a lot on the back end during our preparation to try to make these as valuable and useful and as efficient as possible, which is always our goal for every single one of you. Now, if you're struggling to see results with your current study plan, either you're working with a provider and you're not happy with their service or their support, or you're just not seeing results, even though you're happy with the platform or the product itself, or your results are just not coming fast enough and you're coming up against a deadline and you're struggling to meet that deadline, then definitely head to our website, thegmatstrategy.com, and check out our free video presentation on how to reach your dream GMAT score in half the normal time. That'll give you some really valuable techniques that will surely speed up your process. If you would prefer the process to take twice as long, then please do not watch that video because it's definitely going to speed things up for you. And I wouldn't want you to go too fast if you're not comfortable with that. Now, we do also offer a service if you want a little bit of additional support where you can book a call with us. There's no obligation to buy anything from us. We will just take a look at your situation and make some recommendations for you, whether you continue to stick with your current program or you decide to switch it up with something new. Now, if it seems like it's a fit to work together, then we might talk to you about what our program looks like. But again, there's no obligation. And if you're like, you know what, honestly, I'm not interested in that, then we won't even tell you about it. We'll just help you out, okay? So something there for you if you want it. And a lot of people have taken advantage of it, and we get very positive reviews from those situations. And if that's something you're interested in, then let us know. Let us know. You can go to the website, register for the video, and book a call if you like what you see. You can learn a little bit more about our approach if you like that, or just get some perspective on your situation if that's what you're looking for. So, as always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, head to thegmatstrategy.com, which is linked in the description of this content, and check out our video on how to reach your dream score faster. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. You can do it. I'll talk to you all soon.